So the property that we're going to learn about in this investigation is the product of powers. So I have 2 to the 10th power times 2 to the 3rd power. And I need to figure out, whenever I multiply these two, what my new exponent is going to be. So the first thing I'm going to do is expand it out. So I have 2 to the 10th. So I have a total of 10 2's. And then I'm timesing it by 2 to the 3rd. So now I've got 3 more 2's. So how many 2's do I have total? Whenever I multiply all these together, and I don't care about what the final outcome is, what I want to know is what my new exponent's going to be. So notice how I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this simplifies to 2 to the 13. So my missing exponent is 13. Okay, what about the next one? So 5 squared, 5 to the 4th, so now I have a total of 6 5's, so this becomes 5 to the 6. My missing exponent is 6. Well, in the next one, so this one, it's just a single 3. There's no exponent there, so that 3 appears once. But then I have 7 more 3's. So how many 3's do I have total? 8. So this becomes 3 to the 8th power. My missing exponent is an 8. Well, let's take a look at the next row. So I'm going to work backwards on this one. So for this one, I have 2 to the 7th. I know that. And I've got to figure out what are my missing exponents. So I'm going to list out my 2 to the 7th. 1, 2, 3, 4, 5, 6, 7. So I have 7 total 2's. So I know for a fact here I have 4 of them. So this is 2 to the 4th. So what do I have left? 3. So 2 to the 3rd. So what's my missing exponent? My missing exponent is 3. So is there a simpler way that I can come up with this? Well, let's look at the next one. So in the next one, I have b to the 4th. So I have 4 total b's when I expand it out. Then I have a b squared. So notice now how I have 6 total b's. So notice if I add the 4 and the 2 together, my missing exponent is a 6. So what is this next one getting at? Well, in this last one, all it's trying to say is, what are possibilities that w and x could be? Well, in all of these, notice how I have been, every time, adding my exponents together. 10 plus 3 is 13. 2 plus 4 is 6. 1 plus 7 is 8. W plus 4 is 7. So what did W have to be? W had to be 3. 4 plus 2 is 6. So in this one, W plus X has to equal 5. W and X could be a lot of things. W could equal 1. Well, if W is 1, then that means X has to be 4. If W is 2, then that means X has to be 3. I could keep on going. I can make W 5. Well, if W is 5, that means X has to be 0. So do you see how there's a lot of options here? What you have to note is that you have 5 total 9's. And it really doesn't matter how you clump them together. This one would be 9 squared and 9 to the third. But the 2 plus the 3 gives me the 5. So what do you notice about the value of the exponents? Is there a simpler way to evaluate without expanding? And the answer is yes. So whenever I'm multiplying exponents, when I'm multiplying as long as I have the same base, without having to expand them out, I can add my exponents. So when multiplying, if you have the same base, add your exponents.